Hi folks. Well, like many of you, I have been a happy and loyal customer of Meade Instruments Corporation for many decades. In fact, I can remember when Meade decided to enter the Schmidt-Cassegrain market back in 1980 with their model 2080. I ordered one and patiently waited for almost a year for delivery of my new 8-inch Schmidt-Cassegrain telescope. But let me tell you something, when it did come, I was incredibly happy with my purchase. The build quality, especially the tripod, I noticed that first, it was rock solid and stout. The fork mount, everything was modern looking, it was built well, and I was just tickled. But then when I started learning how to use it, I saw it was just incredibly easy, the learning process of how to use that scope. But the real test, as with any telescope, comes with the optical train. And here's where the Meade really shined. It had superb optics, and that 2080 served me well for many years. And in fact, since then, I've owned 3 Schmidt-Cassegrains, including this latest one, an LX200R 8-inch Schmidt-Cassegrain. Well, as time went on and I got more and more into astronomy, I wanted to, try out different areas of the hobby, and one that really caught my attention was astrophotography. And as I got more into astrophotography, the limits of a fork-mounted telescope at f10 became very apparent to me. And so I decided a few years back that what I was going to do was defork my LX200R and put it on a German Equatorial Mount. This is a Skywatcher EQ6R Pro with belt drive, and I did this so that I could, have better results with astrophotography. Well, unfortunately, not long after this happened, Meade was already in turmoil, and it announced that it was going to go out of business. So luckily for me, I deforked mine before this announcement came, and I was able to sell my perfectly operational, Meade LX200 fork assembly with the control console and the hand paddle, all which worked flawlessly, to another LX user on cloudy nights. And, he was happy and I was happy. But now with the demise of Meade Instruments Corporation, a new challenge came into play. The thousands and thousands of Meade telescope owners out there now had no company to service their telescopes, and especially the electronics. I had to replace a hand paddle at one time with one of my Schmidt-Cassegrains, and so that went away. Now obviously there will be cottage businesses that come up and maybe can service some of that stuff, but no factory support anymore. So I think that there are going to be many more Meade owners that want to keep the incredible optical tube assembly of their Schmidt-Cassegrain, but are going to do what I did. I've got some beautiful Lasmondi dovetail plates here, and this is interchangeable with all the other scopes that I have for my observatory. And so what I decided to do, because there was one thing that was really lacking with this solution here. Meade, my LX200 was optioned with this wonderful microfocuser unit that obviously fits right here, and then the diagonal goes into that, or your camera if you're doing astrophotography. And one of the beautiful features of the LX telescopes, as you all know, is the mirror lock. So you could, obtain a really close focus here, lock down the mirror, and, have less challenges with mirror flop, which is common to Schmidt-Cassegrain telescopes, and then do your focusing with this microfocus here. Problem is, this stereo male jack fit into the control console on the fork mount. No longer have that. Now, there are many different solutions that you could use. I decided I was going to go with a standalone control box that I could just plug this into and operate it from there. So what I've done is I've designed a schematic, and I am going to construct a control box for this microfocuser. Now, given the current state of Meade owners, I thought that maybe some other Meade telescope owners out there might be interested in creating a control box and executing a similar solution to what I did here with my optical tube assembly. So in light of that, what I'm going to do is I'm going to document my entire build process. And so let's go ahead here and leave my living room, and we'll go down to my workshop, and I'll go step by step, show you the tools you need, the components. In fact, I'll have a list of the components in the description down below the video. And I'll take you step by step through building my control box. So if any of you have a like desire to build your own, you'll have something to go on. So I'll see you down in my workshop.
Okay, before we get started with the actual build, I've assembled the tools that I will need and the tools that I may need, and there's probably something that's not here that I will need at some point. So let me just kind of point out to you what I've got. In fact, the view of the camera is not bringing it in all at one time, so let me start at the top here. I've got a drill and some drill bits and a marking tool, which I will use to drill the holes in the project box for the switches, the jacks, and so forth. And I've also got me a Dremel tool here with a variety of attachments here. The primary use of that is going to be to cut off all the burrs on the project box and make sure everything is smooth as we go. Next over here I have a multimeter, an electrical multimeter that I can use to check continuity and test the circuits. Next, going around, I've got two varieties of wire cutters and strippers. Pretty basic rudimentary one that I've had around a long time, and then a newer set of really nice high-tech wire strippers that obviously I prefer at this point because they're so much better. Coming in, I've got actually got a jeweler's loop to look very closely at my soldering joints and the circuit and so forth, just to kind of inspect things as we go. I've got an X-Acto knife. Those are always good to have around to just trim things and cut things a little bit, so I've got that as well. Safety glasses, always use those when you're cutting, drilling, soldering. Of all the things I would not want to lose, my eyes are right there at the top of that list for sure. Got a set of helping hands. That's one of the secrets of getting good soldering joints, is that you let this do the holding and then you can concentrate on the soldering. And speaking of which, I have my soldering iron here, and one of the important things about a soldering iron is you want to get one that has a controllable temperature range here. That's really one of the secrets of getting good soldering joints. The cheaper models, the gun kind and that, they're really not made for soldering, electronic circuits. So you want to get yourself a nice soldering iron. And along with that, you want to have some of this fine mesh here to clean the soldering tip on, to keep it clean. You don't want to have any black oxidized stuff on there as you're soldering. So, and under here you can see that I actually have a working mat, an electronic working mat placed for your little screws and parts here. And this will, protect this this other table surface here from any of the soldering splatter or any of that kind of stuff. And then finally, working way around here, I have a variety of micro screwdrivers and tips to work on electronic gear with. So that kind of rounds out my basic tool setup for the project that we're going to work on today. Okay, I've put together a simple schematic here for my control box to operate my Meade microfocuser. And the first thing I have here is my project box. This is where we'll drill the holes for the controls. And some of you might be wondering why I chose a bigger box. The answer to that is that I decided to go with a full 12 volts, and so I have 8 AA batteries that are going to go into this enclosure, which will in turn lay in the bottom of this enclosure here. Now, some of you are thinking, oh, I don't want a big bulky box like that. That's great. You could probably just use a 9-volt battery. It doesn't have the full 12 volts, but it's got enough juice that it should turn the motor pretty easily. The Meade microfocuser draws less than 150 milliamps, and so it's not going to take that much. But I wanted the full 12 volts, so that's why I chose that. The next thing we want to do is put in a fast blow fuse here, and I'm choosing one that's 0.5 amp or 500 milliamps, and so this protects the motor and the circuit. And so we're going to wire that in before we even get to the next component, which is the speed controller. It's also known as a potentiometer. It's got a little dial on here and a circuit board, and it actually controls the DC motor in the microfocuser and allows it to go slower or faster. Now, one of the reasons I chose this particular model is that it has micro screws here that hold in the wires. And that means that I'm not going to have to get down and do, minute soldering of this on this, circuit board here. So that was a real selling point for me. The next thing in line is the double pull, double throw momentary switch. Now, this is how we will actually, control the forward and reverse motion of the microfocuser by the way we wire it up here on the bottom. And so if you push it the one way, it's forward. And notice how it snaps back to the off position. The other way is reverse. Now, again, some of you might think, oh, that's a great big bulky switch. I'd rather have a little rocker switch. That's fine. Personal preference. Both work, okay? And again, notice how this has screws here. So I'm going to use these little micro connectors with my 22 gauge wire. And it's going to make it a lot easier to, connect those and, fix them, replace them if I have to. And then the final part of the circuit is the female stereo jack here. And when we get to doing it, I'll, explain some stuff, but we're only going to use 2 of the leads on here. And that's because of the way that Meade designed their circuit for the microcontroller. So those are the components. Again, I mentioned the 22 gauge wire that we're going to be using. And that's it. It's a pretty simple circuit. And again, it fits inside this little project box here. So with that, let's go ahead and get started building the circuit. Okay, the first thing that I'm going to do is this project box came with some standoffs in the bottom for a circuit board. And I don't need that, but what I do need is clearance to put my battery holder snug on the bottom here. So what I'm going to do is I'm going to take my Dremel drill and I'm going to cut those standoffs out. Okay, I used the cutoff wheel and the Dremel tool to cut those standoffs off. Now I'm just going to go ahead and smooth the area down a little bit so that it's flush. Okay, nice and smooth. Okay, I have ground down the standoffs and the little casting mark in the middle here. So the battery holder fits in there nice and snug. And when I go to put the lid on, I'm going to just put a piece of foam rubber here to hold the battery compartment in the bottom, and that will work just fine. So we are ready to proceed. Okay, before I go any further, this might seem pretty rudimentary, but you'd be surprised how many problems are traced to very simple things. So what I've done is I've put 8 AA batteries into my battery holder. That yields 12 volts. And I've hooked up my multimeter here on DC volts. And we're going to just make sure that this thing, pulls 12 volts. So we'll touch the positive and we'll touch the negative. And it looks like we're pulling 13 1/3 volts. That's very, very normal. So we know that the circuit works to here so far. So far, so good. Okay, to streamline the process a little bit, what I've done is I've gone and prepared all the wiring and got the ends ready. Whether I'm going to solder them or put them in terminals, I've twisted the ends, stripped the wires and twisted the ends. And I've got one more wire to do here on the crossover, so I'll go ahead and do that now. And strip the wires with these nice wire strippers. Twist the end of that, then do the other side. All right, I have all of the wiring ready to start connecting to terminals and then the switches. Okay, I'm going to start. I've just got a couple of joints here that are going to require solder, and all of the rest of them are going to have terminals. So let's go ahead and get the joints that need solder soldered. Okay, you can see that I have completed the first soldering operation. I've soldered the positive lead from the battery holder to the fast blow fuse holder here, and then I just got a piece of wire that was as long as the fuse, the negative black wire, and went ahead and soldered that as well. I've insulated them with a little bit of electrical tape here. Now, some of you might be wondering why I have such long wires on here when it's going to go in this little project box. Well, what I'm going to do is all of the circuitry is going to be built into this lid here, okay? So when I need to change batteries, I want to be able to remove this lid and set it aside, completely aside, and so I can pull this out and change the batteries. So I want to have ample wire so I can do that. So that's all I've done that for. Okay, the next step is to take the PWM controller and connect the leads from the fast blow fuse and the negative lead from the battery box to this. And if I turn this circuit board over, it says a negative power in is the first one. So we're going to go ahead and take that black lead and we're going to feed it. Make sure that's twisted good. We're going to feed it into that first one there. And let's go ahead and make sure that's nice and tight. And then it says the next one here is power positive coming from the box. And so, let's see, make sure I don't twist up my wires to start right out of the gate here. So we've got that second one in there, and we will go ahead and don't over tighten these. They don't need to be super tight. So again, we've got the negative in and the positive into the PWM controller. So we're this far with our circuit right now. Okay, in order to connect the PWM controller to the DPDT switch, you need to have one end of the wire stripped so that it will go into the terminal here, but we have to put a little ring terminal on the other side so that it will fit under one of these screws here. So I've done the positive one. I've got the negative wire here in the wire crimpers, and we'll go ahead and crimp that one down now. Okay, so now I can attach these leads here to the PWM controller and these two leads here to the center screws here on the DPDT switch. And I'll go ahead and do that now. Okay, folks, I'm nearing the end of putting this circuit together here. As you can see, I decided that I was going to put two stereo jacks out. They're just wired together here. In case one of them would go bad, I'd have the other one. So I just wired those together, and they're going to come up here on the DBT switch. And then I've wired these jumpers here that are going to cross and go to opposite ends of the DPT switch, as you see that I have here on the diagram. And so up here on the top terminals, there will be one of these and one of these on each of those screws there. So I'm going to go ahead and put that together, and then I will show you the end circuit when I'm done. Okay, it looks a little complicated here on the back of the DPDT momentary switch, but as you can see, if we look here closely, it follows the wiring diagram. The positive goes to the middle. The negative goes to the other side in the middle. And then the jumpers, they go from the bottom to the top on each side. And you can see this one here, we only use two of these wires here on these jacks to match the Meade cord from the microfocuser. So we're only going to use the white wire and the black wire. The white one goes to the tip in the jack, and the black one goes to the sleeve. And we don't use the other lead that goes to the ring. So we only needed the two for that. And so you can see that I have the white wires. I have those wired up to this post here, and I have the black wires to this post here. So it looks a little complicated, but not really. And again, I just decided that as long as I had some extra jacks, that I would go ahead and put two of them, just for redundancy, in case one of them were to go bad. So battery to the fast blow fuse, to the PMW controller that controls the speed of the motor, and then to the motor switch, which is wired now so with the jumpers here, so that I can reverse the polarity in this jack here, so that, you know, when it goes one way, it goes forward, and when it goes the other way, it goes reverse. And again, it's a momentary switch, so the minute you let it go, it's off. So that's the finished circuit for the new control box. Well, I've got everything put up. I've tested the circuit, and the circuit seems to be well. So the final test is I've connected my Meade microfocuser to here, and let's go ahead and see if our new little controller works. Turn up the potentiometer. You can see that the little light comes on when it's up. And then grab my momentary switch, and we'll turn it one way. Hopefully it works. Oh, sweet sound. And see if it goes the other way. Yep, I can see it moving out. Perfect. Fantastic. Our little circuit works. Just out of curiosity, let's see if this other jack works. As long as we're doing final testing here. Yep. Fantastic. So if you followed me this far, you've seen me go ahead and build this entire circuit here. We're going to go ahead and put it in this control box here, and we'll come back and do that here in a bit. Okay, as I mentioned at the outset, I'm going to be placing all of this circuitry in the lid and only the battery compartment in the base. And that's so when I need to change the batteries, I can lift the lid completely off. So at this point, I decided where I wanted my switches. Have my potentiometer here, my speed control, and my temporary on and off switch here, and two female jacks here. And so what I did is I measured it, and then I used my nice punching tool here to create a little pit to guide the drill bit. And then I just used a stepping bit to drill out all of the holes to 1/4 inch. And then I took this one out to 1/2 inch, which was needed for this momentary switch here. So now that I've got that all done, I'm actually going to put the circuit into the lid here, and I'll be back shortly. Okay, I have basically finished the circuit. You can see that I've mounted the potentiometer on the left side and the momentary switch on the right side, and the two female jacks here in the front. Now, under the subject of things don't always go as planned, the female jacks that I ordered were not threaded long enough to come through the housing here. Okay, you can see they're almost flush, so I had to use some super glue. I pushed them tight. I went around the ring here, let it dry, and then I went inside and went around the rings in there and let it dry. So again, you know, no project ever goes without some unforeseen contingencies, right? You can see when I was done, I got my little label maker. I like labels. They make things really easy. And O for off on the potentiometer, and F for fast. And then on the momentary switch, forward and reverse. Just very simple. So what I'm going to do now is I'm going to put this thing together, and one of the things that I'm going to do is once I get the battery in there, I'm going to put a little piece of foam rubber here to just kind of hold the battery compartment so it's not moving around. It'll hold it against the inside of here when it's done. So with that, I'll put it together, and then when we're done, we'll give it one more go, make sure it all works with the microfocuser, and as they say, we'll put a fork in it. Okay, that actually was quite a fun little project. It was pretty straightforward, not too complex of a circuit, and it's going to allow me the use of my microfocuser again, which was one of the things that made LX200s so wonderful. This in connection with the mirror lock really helped for astrophotography. Really looking forward to that. So The box is now complete. Fits really nice in my hand. I really like it. It's not something I'm going to be holding all night long, just long enough to do focus, get the focus for astrophotography and stuff, and I can set it aside. It's got plenty long enough cord here, and I could always use an extension stereo cable if I needed to, but let's go ahead and try it out. So this is really nice because it has a on-off switch here. And by the way, the battery compartment has an on-off switch, and so I've obviously turned that on before I sealed this up, and just leave this switch here off. So I'm going to go ahead and turn it on, turn it about halfway, and let's go forward. Let's turn it up so you can hear it. Going forward very nicely. Release it. Now it's going back reversed. And it's really cool because, again, it's variable speed. I couldn't be happier. What a wonderful addition to my astronomy gear.
Well, folks, I'm back with my LX200R and my Skywatcher mount here, and I've gone ahead and replaced the stock visual back that I had here with the microfocuser, the Meade microfocuser that was original equipment when I bought my LX200R many years ago. And I've gone ahead and hooked it all up here with my other cabling. And I've got to tell you, I'm just very, very pleased with the way this thing turned out. And not just because I built it. I mean, that's nice. It's nice to have the satisfaction of doing something yourself, but it's just more precise in its functionality than using, buttons on the LX200 paddle. It's so controllable. Just turn this thing on here, and it's just, with this momentary switch, it's just so crisp. And this potentiometer here, this speed control, is just that is so much more crisp than punching buttons in on a hand paddle. It's more nuanced. And I'm just really, really excited about how this came out. And I'm really excited to get out and put it through its paces and do some actual astrophotography now. It was missed when I deforked my Schmidt-Cassegrain. So again, as I mentioned at the outset, I'm one of those people who was a loyal Meade customer for many, many years. I loved their telescopes. I was very saddened when they went away. But now there is a solution. As the electronics go out on some of them and there's nowhere to service them anymore, we can save our optical tube assemblies and put them on a newer equatorial mount. And with a solution such as this, we can retain the functionality of our microfocusers. So for those of you who are, interested in constructing your own control box here, I hope my video is informative. I hope it helps you, create a like product. And if you have any questions, you can certainly, put them down in the comments section. And again, as I mentioned in the first video clip, I've got a list of all of the parts, the main parts here for this box, down in the description. So you'll have a starting point if you'd, again, like to construct your own box. So with that, as always, clear skies, everyone.